From the application worksheet, I was going to look over the third and fourth problems. They're going to end up being real similar. Problem 3 says an express bus travels 320 miles in the same amount of time that a car travels 280 miles. The rate of the car is 8 miles per hour less than the rate of the bus. Find the rate of the bus. So what they tell us is time is the same. So the bus time is going to be equal to the car time, and time is equal to distance over the rate. So we can fill in some information now. The bus distance was 320, and the car time distance was 280. Okay, now we need some sort of expression for the rates. So speed of the car is in terms of the speed of the bus. So what they say is the rate of the car is 8 miles less than the rate of the bus. So we're talking about it's slower than the rate of the bus. So the speed of the car is in terms of the bus, and so we'd let the r equal speed of the bus. Then the speed of the car would just be 8 miles per hour less than that. So we could fill that in for the rates for both the bus and the car time. At this point in time, you can either cross multiply, or you can multiply both sides by the least common multiple. And either way will give you the same answer. So you have a little bit more work to do, but that's the setup for that one. In problem 4, it's a similar story, and the setup's going to be fairly similar. It says the rate of the bicyclist is 7 miles per hour faster than the rate of the long distance runner. The bicyclist travels 30 miles in the same amount of time that the runner travels 16 miles. Find the runner's rate or speed. So again, this time in this problem they say that the time is the same. So the bike time will be equal to the run time. So again, we'll use distance equals rate times time. If we solve that for time, it'll be time is equal to distance over the rate. So the distance for the bike is 30 miles, and the distance for the runner is 16. Now, we got to find the rates, because time is equal to distance over rate. The runner travels, let's see, we're going to read pretty much the first sentence. It says the rate of the bicyclist is 7 miles per hour faster than the rate of the long distance runner. So the bike rate is in terms of the runner, because we say it's 7 miles per hour faster than the runner. So we'll let r equal the runner, and then we'll let r plus 7 be the bike speed. Okay. And then what we'll do is we'll do the same thing here. We'll cross multiply, or we can multiply by the LCM, which would be r plus 7, and the problem will work out in a similar manner.